Start recording. Okay, cool. Thank you everybody for making it in. Today we have Oleg Lavrovsky, who's joining us from Apertus, and he's going to be giving us a lot of kind of a deep dive into what they've been up to. Thank you for the provocative title, also as well from your team. I think it's going to be something really worthwhile. Just for your context, Oleg, there's a lot of people who are probably in this call who across many places also, across the continent are building their own language models for different reasons. So we're really looking forward to this talk. I think I just want directly to jump in so you can take over and then also share your screen.
Super. Yeah, great. Happy to be here and ready to start. If I can just enable sharing, that would be great. Is that working for you?
It is coming. Just waiting for it. It says you have started sharing. I don't know. Everybody else on the call, can you see his screen? Or maybe just me?
Can't see it.
How's about now?
Yeah, no.
Does that work?
Yeah, we can see it.
Yeah,
excellent.
Great. Go ahead.
All right. So thank you so much for having me as part of your seminars. So my name is Oleg, or O. Sorry. Oopsie. That was a bit of a misclick. One more second. After I start the presentation, is it working now? I'm going to need to make sure that I can advance through the slides.
Yes.
Okay.
We can
That works.
Yep,
okay. Great. So again, thank you so much for having me as part of your seminar series. My name is Oleg, or just O Lavrovsky. I am the technical community manager for the Apertus project. Today I'm at the ETH in Zurich, but I'm also based at the EPFL and working closely with the CSCS. So I'll explain you what those terms mean in a second. Basically, part of a Swiss sovereign AI project to create a foundation large language model. And as I've been following a little bit the work that you've been doing through your initiative, and I think we're all recognizing that we are part of a very small planet, right? We have the Sustainable Development Goals, 17 of them, that kind of contradict what is happening in this very strong rush to embrace AI. And I think there's kind of a general feeling that we have basically unlimited potential in this technology and unlimited energy to spend on it and maybe unlimited tokens to solve all our problems. Well, the reality is maybe quite different to that which we hope and sometimes aspire to. This is a map that we like to refer to from Epoch AI from last year, and it basically paints a picture of the globe where we're seeing a lot of blank and gray areas in countries and regions where AI development hasn't really begun, right? So this is showing in blue and especially dark blue, the fact that in China and the US, it's not just a question of the frontier labs, but actually many AI models are being developed. It is really a technology that has become industrialized and accessible as a source of jobs, innovation, academic research, and so on, right? And Switzerland is that tiny dot right above Africa that is also quite gray, and we're currently one of the very few model initiatives in Europe as a whole. But we'd like to really put the global picture on it. So the Swiss AI initiative was started very recently and already has something like 1,000 researchers involved across academic institutions in this country, led by the federal technical universities of Zurich and Lausanne, and really enabled by supercomputing infrastructure that has been under development and available mostly for government work, for weather forecasting, calculations of all kinds, economics, and so on. And now there is an Alps cluster within the supercomputer infrastructure that is really ideal for doing data science work that has been already the focus of various machine learning efforts. And the Swiss AI initiative distributes access to this supercomputer. So there's about up to 20 million GPU hours, which are distributed in grants in small projects and large projects. And if you're interested in this, you can actually partner also with Swiss institutions to gain access to this infrastructure through a grant program that has rolling reviews for small projects, and twice a year we will have an open call for large projects. So basically, we have this map of Switzerland, right? And like the map of the world, we also want to paint it blue. And what's notable about the CSCS is that it's very close to one of Switzerland's largest bodies of water, Lago Maggiore, and it's actually a strategic position for that infrastructure. So the CSCS is an organization that develops and operates this high performance computing, and now it makes it accessible towards projects all around Switzerland. And since November of last year, Alps was actually ranked as 8th in the top list of the world's most powerful supercomputers, with a notable performance of 434 petaflops. So if you want to compare these numbers, there's a lot more details on the Top 500 website about the performance. One thing that gets overlooked a lot in these discussions is the emissions question, right? So we have within this particular cluster done a little bit more analysis to understand the power draw, which is around 7 megawatts. And over 90% of the electricity is being sourced from hydropower. So yeah, these mountain rivers feeding into the lake, they're the source of electricity. And there's this thermal power plant that is pictured on the right where waste heat is being recovered. This is not a primary research objective of our project, but there are studies ongoing, such as the power usage effectiveness evaluation. And if you're interested in sustainable AI, please reach out. We'll connect you to those. So basically, we have this Swiss National AI platform, and we are a universe of inquiry. So across these thousands of researchers, we have many topics being discussed and developed and powered by this infrastructure. And Apertus is one of basically the flagship projects, right? We have a very large reservation on the cluster, which obviously has peak times during intense training runs, but essentially we are doing all our work on Alps. And we have produced two LLMs, two models last September with Apertus 1.0, which are available in two sizes. So an 8 billion parameter version, which takes about 16 gigabytes of hard drive space, and 70 billion parameter version, which is really aimed at server class, like more industrial deployments or for many users and so on. The three research goals of the Apertus team are having full transparency. So we're developing our own open model in order to research and develop these AI systems without being, attached to commercial providers of any kind, basically being able to decide the direction in which we want to go, and having this freedom to make architectural decisions or just, again, like be based completely on our own infrastructure. And it is open to really for everyone also to kind of look at the roadmap and suggest changes and so on. And the model is trained on 15 trillion tokens of text data, the original version. So that's about 60 terabytes of raw text, if you like. I noticed in one of your recent presentations, you were talking about this, I think, level of data source availability also. So this is the kind of big data source that we're talking about when trying to train large language models. This is a very big model because of the amount of data going in, not especially because of the end size of the parameter count, but because of the amount of data that we're processing. And what's really important about this, and I'll come back to this later as well, is that all of this data is also open. So not just the model itself, not just the weights of the LLM, but actually the data that is behind it is also accessible. It's part of a transparent data pipeline. So training this model required up to 4,000 GPUs for about 3 months. So that just for the larger version. So we've been working this pretty much continuously for the past couple of years. And the results are on the right for that initial release. You can see that we're kind of neck to neck with models similar to ours, such as the Quen 32 billion model or the Llama 70 billion. And in Europe, we have the Euro LLM project, which is done by the joint HPC clusters of various other supercomputing facilities around Europe. We work very closely with like the Supercomputing Center in Barcelona. We have joint seminars, and we definitely compare the results and see how we're doing there. And GPT-OSS is probably the best known open weight model out there, created by OpenAI, shared, kind of as like a tech demo, you could think, but actually having, very strong capabilities for coding and all these kinds of things. And has been, together with the Llama and Quen and DeepSeek, really has been paving the way for, matching or even exceeding in some cases frontier capabilities using an open alternative. So that's just the benchmark for English on the original release. Um, just to quickly say, Apertus is available. You can download it from Hugging Face, or you can access it on various cloud providers. We work closely with the Swiss National Telecom, Swisscom, as well as a range of other companies. And folks from AWS or Microsoft have also made it available on these global cloud platforms. But this is really outside of our scope. We do not provide the platform outside of the research community, and also very locally. Right now, we're really focusing just on developing the LLM. We open it up, upload it, and then people take over the task of hosting it. And if you want to run it yourself, well, it's compatible with VLLM, SGLang, Llama CPP, and so on. And this is popular open source software that you can use to run a model like ours on your laptop or in your server farm. So really, this is really well established, and we try to make Apertus as compatible as possible with the model weights from other vendors and research teams like ours around the world, which there are a growing number of. So we are tracking at least a dozen other teams around the world doing this, and we try to load our various models and compare them. The license is Apache 2.0, which is a very popular license, well known in the open source community. It has no commercial restrictions, and it is also not a share-alike license, so you can redistribute your product under a different license if you need to. And one more thing that's maybe interesting, I think, for us to develop an international connection around is that we have a nonprofit called Public AI. They're building the first AI cooperative. So they're pulling together resources, they're getting donations of computing ability, and trying to create really a non-profit model with a low barrier of entry, low cost, that is aimed to democratize access to just fundamental inference on sovereign models. And they're doing this in countries around the world. So there are already local chapters in various places, and maybe it'll be interested for you to have a look to see what they're doing, and they've been definitely helpful, especially in the launch of the first model to get it available across Switzerland. We also, in June, released Apertus Mini. These are just additional model weights going down to 500 million parameters, and then a 1.5 billion and 4 billion parameter size, which is, like a scale of 10 smaller than the original release, and it's a demonstration of the quantization technique. We are not promising to support this. There's a paper. We have interest to continue this work, but it's really all about to see how much performance can we get out of the model when it's down to the size that runs on a smartphone, or even one of these microcontrollers for embeddable use cases. And we found that the performance is actually quite good. So you have also much less power draw, obviously, from such a small device, but you're not getting like 100 times less performance. You're getting something like on the order of 10 to 20 size less quality of results. So it is still a conversational model. You can still solve a lot of tasks and develop use cases with it. And yeah, this paper was just presented, and you're welcome to have a look. So that's what we've been doing with the original release. So this is still based on the same data, on the same model that was available since September. And for the past 2 weeks, we've been focusing on the release of Apertus 1.5, which is the continuation of the training of the 1.0 model. So this is very new. It's available to download right now. And some providers have already made it available. We're still working on the technical report. There are no really final benchmarks results yet. What I can say is that we've added 4 trillion tokens to the 8B model and 2 trillion tokens to the original data, to the larger model. So there's a lot more data that's gone in. We focused on these strategic areas. So we've looked at health and education and justice to see how we can improve the model performance for kind of particular use cases. And the big thing is multimodality. So we've added audio and image input support. Until now, Apertus was just text to text. Now it also understands images, understands audio. And this adds also overall perceptual specificity. So the model can better disambiguate things, better understand certain topics. And there's a much longer context window. We've increased it by a factor of 4. One thing that we've been struggling with over the course of this program, I admit it, this is a really tough area for research and development in AI today, is the whole aspect of reinforcement learning. So we're really committed to improving the instruction following. People in the industry, people who are developing real world use cases, not just academic evaluations, they really want to make sure that the model can be used in coding and reasoning and agentic contexts. So this has been added. We have now thinking mode. We have better support for MCP, these kind of like remote services that the model can call on. And this is thanks to some additional techniques in the fine tuning and the final post-training of the model. But we're still very far away from really being able to deliver on a lot of the expectations that are in the market for these models, partly because we do not employ any data workers in our project. We have no human in the loop. We have some data gathering activities that have been evaluated. For example, there is the Romanche language, which is specific to an area of Switzerland, and it is well known that even though it is a national language, acquiring data to it is pretty hard. So we have created some crowdsourcing tools, worked with some groups, also in Swiss German, which is another local dialect of ours. So we've kind of demonstrated, we have some open source code that shows how to collect this data. But when it comes to the actual interaction with users, collecting the prompt data, there is a lot of hope on the inference providers creating opt-in mechanisms and creating data sharing agreements with us, and really also clarifying the impact on privacy when that happens. But we have to be very, very careful here. This is an area which is fraught with ethical and legal pitfalls to really set up a very good reinforcement learning platform is hard, and this continues to be a big challenge for us. So anyway, long story short, we're working really hard to train these models, and 1.5 is just fresh out the door, and you should download it and try it. I mentioned the tech report. So this is what we're working on right now. We're updating it. This is like one of the first publications which really explains end-to-end how to build a large language model. And it goes into a lot of detail, and it shows how we trained it, how we collected data, how we evaluated it, and everything's available, including intermediate checkpoints. So you can actually download the model weights at different stages of the training process and continue from there. So you can do continuous post-training, or you can do fine-tuning. There's various techniques, and the technical report shows you how, and we've been rated quite well on the results. And this was just presented in July in San Diego. So there's already a lot of like interaction with the scientific community, lots of citations, and we're really hoping that more people would see the advantage and see the possibility in not training a model from scratch, but actually starting from what we're doing and developing their own solution. And one of the things that the report talks a lot in detail is the responsible data practice of the project. And just to give a glimpse into that, maybe you've heard that in Europe, we have the EU AI Act coming into force next year. This is kind of a revision of the legislation at the European Union level that will require much more stringency around the way AI gets developed and deployed and used. And we're one of the first teams that are researching this. We have a legal compliance interest group, and we've really tried to embed the key parts of the EU AI Act, the drafts that are, or the documents that are available now, and are referenced, and are also, we have a constitution inside of the project that makes it very important for the model to follow legal instructions and legal regulations. And in addition to that, we also have some innovative techniques to deal with some of the implications of those laws. to make sure that we do not reproduce copyrighted works, to make sure that we actually respect the opt-out preferences when people do not want their websites to be scraped or crawled, even retroactively, if we detect that within the data that was collected by others, there are copyright issues, licensing issues, personal information issues, and so on. We make a lot of effort to try to try to mitigate that. And that's one of the kind of, I guess, advantages for, let's say, Swiss companies or European companies right away if they would try our model as an alternative to other AI tools. And maybe this is also something that is in the roadmap for your country's legislations as well. So with that said, we're really like to position this as a global project. We're super happy that it's been downloaded millions of times already. I mean, we're still just fresh off the ground, but there's an active and vibrant community of open source contributors, not just starring our projects, but actually helping us with the key tasks. And one of the main issues for us is the fact that, once you have these model weights available, making it actually possible to run the model, to deploy it on a server or a computer, needs work. And often that is the work of making sure that things like the chat template and other aspects that are, different in that particular model are supported by libraries and open source tools. And so we are absolutely dependent on third parties, other organizations, companies, research labs, testing that compatibility, implementing patches. Sometimes it takes many months to go through this process, depending on the library. So not everything is available at the same time. But we just do not, we're a very small team. We do not have internally the ability to support every format. And the same thing for quantizations, right? We have tested some quantizations, we've benchmarked, we've proposed a pipeline, but really there are communities out there that take these models and process them and make them available in all these formats. There's no reason to duplicate their efforts. It's more of a question of understanding which ones of these are actually high quality, which ones can we recommend. And finally, the fine tunes. This is the thing we're most excited about. This is when people take Apertus as a foundation model and build on top of it, adding regional capabilities and support. So if you have, let's say, a Swahili language data collection that you've curated, you could fine tune Apertus and create like a Swahili version of it with that curated data set that would enhance its abilities and also even add other capabilities. So, for example, it could be an instruction following technique, or it could be a completely different knowledge domain or action domain. Like if we have people working with robotics and vision projects and so on, and they can mix and match LLMs. So it's not just about either or. You start creating these sort of architectures of AI in platforms where also the LLMs can be mixed and matched together. And sometimes it makes sense to really bring those model weights, those neural networks very close together and actually combine them for a stronger model. One really good example of this is what AI Singapore has done with C-Line. These are the Southeast Asian languages that they've fine-tuned the original version of Apertus with. Or we have also another laboratory that is distinct from ours in Switzerland, that's created the world's first fully open medical LLM called Meditron, which is based on data from patient exchanges, which is really actually undergoing clinical trials in hospital setting right now. We have nothing to do with that except they were able to save a lot of time, energy, and expense in starting with Apertus, and also have a sovereign and fully open solution from the start. So that's the kind of like collaboration I hope we can also achieve if we partner with communities across the data science labs around the world. Just to conclude with
just for now, I was going to say, just for you, we had Annie gave a talk last year from the Move team working on Meditron.
Super.
Yeah.
Okay,
So
you know what I'm talking about.
Yeah.
Fantastic. So I wanted to share a quick demo. This is from one of my holiday pictures. I'm standing next to my daughter and a gigantic statue, and I'm asking the model to describe it in one paragraph. And you see the description is that is readable, it's understandable. Large, glossy, black-brown statue of a young girl. In the foreground, two people, a woman and a man, looking at it with interest, etc. It even tries to read the text behind us. You can kind of see partially obscured by a truck. There's like a poster, and it actually transcribes those words reasonably well. So we have really, OCR capability. right out of the box, and the image recognition is pretty good. I also like the description of the wet pavement reflecting the overcast sky and so on. And of course, you can do this technique in any language. You can output you can tell the model to do the description in any one of the potentially in the 1,800 languages we already support. Although it will be particularly good in high resource languages and less good in other languages. And here's a quick demo with an audio file that I downloaded from Mazungumzo ya Kwanza. I don't know if I'm saying that right, but it's kind of a Swahili instruction manual from 1979. And I have absolutely no ability to determine whether this is a good transcription or not, but already the fact that the model automatically understands that this is in Swahili language is great, because there's nothing in the file name that indicates Swahili. So it really had to listen through the audio response, and it is what I expect it to be. So it's from a textbook kind of conversation between a teacher and a student, and yeah, the model seems to be doing quite well. But we would love for you to test this yourself. So this is really like an open invitation to kind of join us in a way, because we are continuing to train Apertus. We're already starting. We're close to starting Apertus 2.0 training run. This is slated to come out in 2027, in time for the AI Impact Summit in Geneva, which will be quite a momentous event for everyone here in Switzerland. And we hope to welcome to the world to Geneva and show what we're doing in these domains. So that's really our deadline. And we're even hoping to release an update by the summer of 2027. And if you subscribe to our newsletter, you will be among the first to know when those are available. And of course, on the same website, there are contact links and source code links and so on, where you can engage with the community. So thank you very much. There's an email address that goes to all three centers. So the tech leads, so myself and the various people involved will get your note if you have an interest in a project or have tried fine-tuning. Apertus would be very happy to hear from you. I hope that gives you a nice little intro. I stayed away from going into too much detail about the language capabilities. I wasn't sure how much you wanted to know, and also we don't have the data quite ready for the latest release. But I'm here for your questions now. So I'm happy to open up and dig in more into the details now.
Okay, thank you very much. Just because of where I am, Manala, can you just keep track of people who might be open to either asking a question? People can raise their hands, and then Manala will acknowledge you, and then you can unmute and ask your question. Or if Manala, if there's a question that's actually written in the chat, if you can read it out for Oleg, that'd be great. I think I'll kick off in this case, Oleg. In terms of, if you can tell us a bit more about the data curation in terms of finding all of the data, cleaning it up, keeping track. We said 1,800 languages. How do you confirm that? Those types of things. And then on the other side, I know you say you have 4,000 GPUs on the other side and a number of millions of GPU hours. But then if somebody is working on the other side of that scale, not that much, but could be thinking about continuous pre-training and some fine-tuning, what might be some of the things they should think about? So yeah, the data, and then being more clever with using compute.
Okay, so the data question is super interesting to me. Like, also maybe just to add a little bit of background, I've been involved with the open data movement for many years before joining this project. And to me, essentially, the AI models represent the current approach to just compacting big data to a more efficient and accessible way. But of course, the major issue is the loss. I mean, our main curation is like the loss function. As we go through the process of training the model, how far removed are we from data sets? And essentially, we go through about 5 phases in the training. which starts with a very general ability to understand syntax and to just to really to build a response from one token to the other. And we distinguish among the different data sets we use according to this these phases. And essentially you want large text corpora for that initial phase. We use kind of the outputs from the Common Crawl project, in particular the FineWeb 2 team's effort to deduplicate those different regional dialects, to improve some of the formatting, and to create more efficient pathways to ensuring compliance, legal compliance. Those are kind of the things we benefit from there. And we have to depend on a lot of this pre-curation by those community efforts, right? And essentially, until they provide us with an AI-ready data set that is accessible and verified, like legally accessible, we wouldn't use it at all. We have a lot of people approaching us now and saying, well, we'd like to donate data and so on, and we're like, well, that's great, but you don't you have to realize that if we use your data, we also need to be able to reference your data. So they actually need to go through that step of publishing their data online as open data. And again, we would not also accept data that is under commercially excluding licenses or copyleft licenses. So that's also an issue with very large data stores, including Wikipedia, that we cannot use currently because of legal restrictions. So this is all outlined in the technical report. Also, actually, you don't even need to wait for the technical report. If you're interested in this on the model card of the current model 1.5, there is a link to the kind of a spreadsheet where the data curation is pretty evident, and you can see, for the different stages, but also for the different modalities of the model, what are the data sets we're using under what licensing terms. Sometimes the licensing is on a row level. So you have certain data sets where it's not one license for everything, but you actually the data pipeline has to really do that in the process. And you can learn more about that through kind of going through our data pipeline sources to see how we do that. But yeah, it's still it's a lot of manual work. We have kind of our data team that goes through, evaluates. Mostly, I would even say it's not even enough for the data to be available. As we're a research team, we rely a lot on research recommendations. So we tend to use data sets that have not just been published, but also cited, that have a paper attached to them where, there's some kind of institutional validation as well, and some at least some clear evaluation has been done on the quality of that data as well. So yeah, it would just be impossible for us to so quickly scale up our work if there wasn't this research network around us. As to your other question in terms of like best practices, I mean, I've been supervising some students who are doing fine-tuning work on the not even on the supercomputer, but just on the data centers of our local university. So it's not, I don't think there's really like a bottleneck there. It does take an effort to understand, what does that really imply, and and really to set the expectations correctly. Currently is quite hard. There are a lot of, I mean, there's these, vendors selling a very magic solution, and you need to be aware that every time you take a large language model and you affect its composition, its weights, even its kind of outer shell of chat templates and system prompts and so on, you're potentially degrading its quality and performance and capability. And that's it's kind of like a balancing act. You're adding maybe high quality data sets from that are uniquely accessible to you, but you may be degrading the abilities of the model to reason in some other language, or to do some kind of mathematics or something like that. And that's why we say that ideally we would like to incorporate high quality open data sets into the next release of the model. But it is also very, very helpful for us when teams independently try to do this. But there's just various levels and techniques, such as continuous pre-training, which you mentioned, there's all the way down to LoRa. Like LoRa is currently the technique that seems to be easiest, but it's also the one that's a bit most precarious. So, and there's really a gradient to that. We have some recipes for fine tuning on our linked on our webpage. There's like a documentation area, and there we try to explain a little bit the difference between those different techniques and give you some sample code to run on your own infrastructure. And I'm very happy to provide some tech support or some advice for anyone doing that kind of work. And always happy when those results get published on Hugging Face or somewhere, so we can also download and verify the results.
Cool. Thank you, Oleg. So Martin posted in the chat. I think Martin's part of your team.
Mhm.
Yeah, so he shared some statistics regarding the availability of African languages in the model. So I thought that was interesting for everyone to read. So there's about 512 African languages available on the model. The data comes from FineWeb 2 and mostly consists of New Testament translations. So that's really cool. Thank you for that. There is a question from Crispin. I don't know if you want to ask your question, Crispin. Switch on your mic, or if you just want me to read it. But his question says, what are the available use cases with the current Apertus version? How do you address legal compliance with regards to data and ethical perspectives?
Okay. Yeah. So first of all, thank you, Martin, for sharing that, and definitely we need to make maybe more effort to make those quantities visible on the webpage and so on. So it's a good tip for me. So Crispin, thank you so much for your question. We have actually just yesterday updated also our webpage with a new showcase. So we're trying to track the use cases, even though I have to say, like our goal is really like that fundamental training regime. We don't currently partner with any organizations to create products with Apertus, right? So from my perspective, essentially, any use case is good. These LLMs are pretty universal instrument, especially at that scale. They could be used to address any kind of problem. And we're trying to, like I said, track a few of those. I have a database. I know that there's about 50, 60 different pilots going on. In particular, within the government administrations of Switzerland, we have some visibility into, also it's been published, the fact that some governments are creating internal translation services and so on, which is like the easier thing to develop. And having more of like a decision assistance, some kind of an analytical tool being maybe the more ambitious use case right now. And yeah, addressing legal compliance with regards to data and ethical perspectives, it's a constant effort. Every release, we work with legal teams, both internal and external. We get a lot of review. We get contacted by researchers, and they fine comb through the data. And I think this is just the commitment that our community needs to be ready and willing to make to say, look, we know our quality and our compliance is not good. We admit that it's not good, but we are also committed to continuously improving it. When people contact us with removal requests, we address them. We make sure that data gets removed, filtered out. If they're, but a lot of people have concerns which are more like at the quality level. And there, I would say people should try to really download that. Have a look at the Swiss AI Charter. We're renaming it as just the Apertus Charter, but that's basically a small text that outlines those ethical perspectives as we see them. But we really need to have a democratic and open dialogue around this. We're really keen for people to send revisions to that charter and even make alternative versions of the model running on, because basically the system prompt is something that you control it, and we recommend a system prompt that references the charter and making it clear why the model pushes back on certain things, making those guardrails a bit more tangible. But you can also change those system prompts to focus on a whole different set of rules. There are certain things the model will just not do based on without massively changing the weights, right? Without basically reverse engineering the model or by creating your own post-training version. But essentially, it's great if people experiment with those boundaries. And part of that is this red teaming effort that we also work with internal and external groups to try to understand the safety parameters of the model. But these are almost like these are very distinct research goals. They're even the focus of other institutions, and it's really a collaborative effort. And it's a little bit like what happens within the Linux community, where there's a group developing the kernel, but then there's another group developing the drivers, and yet another developing the firewalls and the security tests and so on. So yeah, it's just not something we can just solve overnight, especially not with limited public funds that we have available.
Thank you very much for that response. Caspar has his hand up. Do you want to switch on your mic, Caspar, and ask your question?
Can you hear me?
Yes, we can.
Yeah, Caspar.
Okay, so we are currently working on some SFT work, and we've been experiencing a few challenges. I think one of them was that our models seemed to be plateauing. The performance seemed to be plateauing before the model has sent all the data. So like way before like even one epoch. And after looking at a few things, we saw that there's a couple of reasons why this might be happening. But then also one of the challenges was that when we've got like a lot of data, right? We saw that sometimes if you're dealing with a smaller model, it sort of like reaches a point of saturation where it cannot like take in more data, like it cannot learn more new things from the available data, given that you've got so much data. So one of the things that I was that we're trying to figure out, been going through the literature and all that, is when you're dealing with like a large number of languages and you're doing like multitask fine tuning, right? What are some of the from my experience, what are some of the techniques that you can use to sort of like sample the data? Like the literature points to like some techniques which may require you to like, one paper was saying that you can use an LLM to grade the data, then you can, find high quality examples, then you can train only on those. But then that seems like, a lot, because now you have to like run inference on another model and all that. Are there any like techniques that are, that you know of that we can use to like sample data for like a multilingual and multitask fine tuning, given that you've got so much data and it varies in quality and you're trying to sort of like train on data that will help the model the best?
Super question. Thank you. And like you referenced a couple of important things that I forgotten. One is that we not just have the research report, the technical report, we have a growing collection of papers from the Apertus team. You can also find a link there to a Zotero library. So we're compiling citations and just literature we find of interest. And what you're asking is definitely like in the domain of training and being able to scale up across this. And yeah, the essential. Also, this is also not easy for me to answer because this touches upon a lot of work that people are doing around in the team. And but I would basically say that we are doing SFT. In fact, there's an Africa SFT project with which was used by our post-training team in the original Apertus release. I put the link up there on Hugging Face. And there you'll also find the GitHub repository to those SFT scripts and to see how we're dealing with deduplication and in there. But it's a continuing discussion, right? The thing with SFT is that you're also having these various scenarios which sometimes contradict and conflict with each other, right? You have these sometimes you have just a classification response. Sometimes you have more of a kind of a debate. Sometimes it's descriptive and sometimes it's more prescriptive. And so you again, like without having a human in the loop going through, and really annotating and tagging those into specific categories, we have to rely on automated techniques there. So, we do use stronger models as judges to evaluate some of the tasks during the training. So, some of that remediation work is being outsourced. And one of the important infrastructures for us is a cluster where we can fire up other models and see how they respond to a particular data mixture and how can they help classify us. And in some cases, we're saying that we need to generate synthetic data that is a better, kind of like a compromise between these different issues being involved. But being a completely open model means primary data sources, and we're not really ready to publish and support synthetic data sources. So it's a bit of a tangle. DPO has been a technique that we've used in the 1.5 version, so you can read more about that in the upcoming technical report. And we'll probably have a section where we actually compare it, because we had a lot of debate just in the last months before the release about which kind of technique was best, and we actually tried about 5, 6, 7 versions of the model in parallel to try to really gauge what the influence of these methods were. And I mean, that's the basic answer. It takes experimentation, or ablations as we call it, right? Lots of little tests, and having being able to afford that, having the time and the infrastructure to test various techniques in terms of reproducing methods, in terms of getting validation from other automated systems, and then really pulling that together into a single training run, single reproducible pipeline. That's essentially the trick, and mixture of experts is going to be what's on our roadmap. So the MOE architecture has already been embraced by many other labs, and we're also going to adopt that for Apertus 2.0. And also, I think there's some clear opportunities there to distinguish the different kinds of tasks that are being done, and not having to have a single dense model or multiple versions of dense models like per industry, but rather having a mixture of extra approach makes sense. But we're not really there yet. We're just starting the pre-training right now. I hope that helps. But really, please approach our research team by email for a more detailed response.
Thank you very much. So there's a question from Timo. So you mentioned OCR capabilities that the model has. So the question is, what's the OCR configuration, and why did you zero down to that specific one?
Yeah, no, I mean, I'm not sure I completely understand your question, but I kind of I mentioned that the model can do OCR. It is not an OCR model per se, right? You can feed it a text, and we have had a lot of data in the last release, which is basically scanned documents, scanned pages. We have not really optimized for OCR production, so you will find much smaller, more efficient OCR dedicated models right now. But yeah, it's kind of like a basic expectation from any computer vision tool. It's something that is hard to do perfectly, or maybe even impossible. Not even humans can read everything perfectly, right? I mean, it's a lot of it has to do with the interpretation. So for me, just being able to read text that's inside of that photograph or inside of a document is a good validation that the model is doing precise text, that it has a good text interpretation model, and then you kind of see how well that mixes with the cultural understanding when you're trying to read scripts from different languages, right? To see if we have actually an overall better cultural perception. I think that is going to be an important set of evaluations for us to follow. Yeah, hopefully that's the response you were looking for. Otherwise, yeah, just ping me if you want to know more details, and I'll try to get you a little bit more perspective on OCR.
We have another question from Bello, Umar Bello. The question, okay, firstly, thank you for your presentation, my question is, what is that Oh, what is the biggest limitation of the model today that you believe researchers outside the core development team could help solve?
Oof. I think we have so many limitations. We are a project we are, it's about the constraints, right? Um, I mean, the maybe the sustainability one is one topic that I mentioned that is something that really is not a focus area for us, but I'm seeing some interest from the outside to understand, the total kind of costs of investments, like the total carbon footprint of a model. And we're trying to do a better job of inventorizing, the components of the data center, provide that data so researchers could evaluate that, for example. Although we're not going to really do much work on it, or at least not right now. I think when it comes to the core research areas like multilingualism, I mean, I actually learned about Apertus while outside of Switzerland. I'm Swiss Canadian, and when I was in Canada at a hackathon, I with the AYA team, they were developing multilingual model, and that's when I actually learned that there was an effort like that in Switzerland, and they were sharing, they were co-developing a benchmark called Include. So I think this is also a very easy and good starting point to create your own evaluation pipeline to test not just Apertus but various other models, to create good Q&A, like to examine the model with data that would not be already within the model, right? To avoid that pitfall of bias, and to see if there are kind of angles which are currently not covered by linguistic interpretability. I think there's a lot that we can still do in really this kind of cultural contextualization. How well does the model go beyond kind of just syntax and grammar? Because we've had spell checkers and grammar checkers. That's nothing new, right? But can we, can models really like create linguistic patterns that we can associate with a specific audience or specific kind of mode, like newscasting or whatever. So that's one area, and definitely performance is always going to be welcome as a form of collaboration to see, are there optimizations that we can do around the model's ability to just kind of basic tokens per second type of performance, as well as just the many quality factors that are involved in other use cases. Like, I've mentioned the compatibility with open source frameworks. For example, making it possible to use LLMs in conjunction with geographical information systems, or music creation tools. These kind of things take right now a lot of pioneering effort and are being done by amateur and industry user communities. In research, I think we're still kind of in a bit of an isolated field. LLM development is emerging out of the data science field, so we understand our if our loss curves really well. We really think very functionally about the training runs. But when it comes to really like the whole aspect of the impact of the model, there's so much social science also to be done around, the legal implication, which we briefly discussed, and the ethical ones, but also kind of like the cultural transition that the world is going through as people adopt this idea of augmented intelligence. So we have like a crutch for our brain now, and what does that do to our institutions? What does that do to learning and so on? So I think there's um, a universe of questions to explore around that. And one thing that maybe I'll suggest, just because yesterday we had a solar eclipse, especially like in Spain and Iceland. I don't know how many of you followed that. I don't know if it was very visible in Africa at all, but I was up on a hill last night with my family, watching a 90% kind of and as just like I was thinking a lot about how we relate to the universe, like through the lens of astronomy. There's these planets and stars and things to discover out there, right? And in a way, an LLM is a bit like a universe of knowledge, right? We have this very dense, neural network representation of all this data, and even just kind of, exploring it and naming things and structuring things, I think also is just a fascinating domain of research. And it's a little bit like with my students, I've been working on knowledge graphs and exploring, graph traversal with powered by LLM. So I think there's already fields of study which are super developed, which we can link to this. But I think just having this fundamental fascination is something that all researchers can do, and it would be great to see more, global collaboration across different scientific domains and cultures there.
Thank you very much. In the interest of time, I think Jean's question will be the last question, but there are three more questions that we'd really appreciate if you could answer. So I'll start off with Hawa. So Hawa is a member of the Data Science for Social Impact Lab. She's also working in the same project as Caspar, so the LLM project. So she is currently running a small proxy study comparing continuous pre-trained strategies for adapting an English-centric model to African languages, measuring African language gain against English retention across few arms like replay, model merging, and EWC. She's testing on Gemma 2, which is architecturally different from the later models. So her whole design currently rests on the assumption that what she sees at small scale tells her something about what may happen at large scale and could help form later decisions as we build our LLM. So you validated and revalidated your data mixture choices at different ablation sizes. Did the ranking of those interventions hold as you scaled, or did any conclusion from the small scale ablations reverse? And is there anything you'd warn a small scale research like this one not to trust?
It's a beautiful question that I really would want a pre-training engineer to respond to. There is, I mean, clearly there's a huge potential in developing tiny models, doing those small scale ablations. We have uh, we are working with also we're testing models like Gemma or Kimi or Quen, and the smaller versions are very convenient for testing various designs. Um, I don't I can't think of a particular thing. There are a number of changes that were double backed upon in the first release in the report that's available now. Just to give you maybe one example, there was like the scale attention that was changed, and we actually went back on training with FP16 and I had to stick with FP8. There's a lot of issues with the batch size, as I recall, and like right now the things are moving so quickly that I think our main problems is just holding on to a vision of which like architecture we decide to, and it's kind of to the point that you just need to agree on a set of parameters and scale back your ambition correspondingly to really be able to complete those experiments at scale, because things are not one-to-one. We do get surprises. We do need to adjust. We do have those phases so that we can reassess in between these multi-month training runs. And yeah, I mean, some things you really can't do much about, like the quality filtering of the data and so on. I mean, yeah, in post tuning and so on, but like in the foundation model, you expect there to be a number of issues and concerns. One thing also, like I think with with smaller models, you can see like to what extent you're able to have a linguistic capability that is appropriate for a particular use case. And we're seeing people creating like this medical model that I mentioned, that Anna already described to you, that would be maybe having some particular properties, or like function tuning, right? That's another area where you could create models that are very tuned to your engineering workflow to call specific functions to work in a particular programming language and so on. right? Using a small set of data and having those probabilities in there focused. But yeah, like I'm going to just have to ask you to wait a little bit for the 1.5 technical report. Have a look in the history of 1.0. There's also a little bit like the community perspective, I suppose, starting to emerge. We're no longer that new, and people who are also, fine-tuning and creating their own Apertus mixes might also be running into issues. I've heard some people taking that Apertus mini model and doing small experiments with it and asking some questions around scalability. But if you're really kind of dedicated at that point to building LLMs, also have a look at our open source large language model builders summit. It's a set of videos that we uploaded from our conversations with people like who are doing similar things to you around the world, and yeah, you're going to get a lot of content there. Yeah, this I think you're opening up like we could talk about it for hours about that. If there's one thing that's not to trust, I think it's really like the reliability of the infrastructure has been one issue for us. Like being able to work with those, and it's a bit of a pet peeve of mine that we are very much beholden to, like the graphics cards from a particular vendor, and the data science libraries from which are kind of work within a particular framework, even if they're very, open source and very global and very permissive in nature, we still have like a very strong dependence on the high quality engineering support, and not being able to really use also other kinds of clusters and work in a more federated way, or distributed way, across the various data centers. That's also something that I think your kind of question aims to address. Like, can we actually reproduce this model building effort elsewhere? Does it need to be at supercomputer scale, or can a much smaller data science cluster be used? I think having not just the transparency, but people asking critical questions like yours, doing some having those open conversations among the engineers would be great. So yeah, and please consider coming to our next Builder Summit or event. We have an event on the 1st of October in Zurich where we'll have workshops with the team. And I can, if you subscribe to the newsletter, you'll get an invitation to that very soon. Yeah,
Thank
sorry,
you.
we're probably out of time, probably over time
Yeah,
now.
okay. Do you have time to answer the last two questions?
If,
The
yeah,
one,
I mean,
oh,
I don't mind answering a couple more questions if you are fine with that. I'll try to be very, very quick.
okay, cool.
Because I do have.
Sorry, oh, okay. The last question has to do with the model being used to evaluate finance data.
Mhm.
So our concern is memorization. Can fine-tuning data be extracted from the model afterwards, for example, client data? And would you recommend RAG over fine-tuning to keep sensitive data out of the weights?
Okay, there's a great question, because the finance industry is very big in Switzerland, but they've only recently, like, I guess, really acknowledged that Apertus could be worthwhile. There's a kind of an interest group starting out right now that is asking a lot of questions like this. But the basic response is, anti-memorization technique, the goldfish loss objective, ensures that up to a size of 500 tokens, you're going to anything beyond 500 tokens, sorry, is going to be unique generation, right? So it depends a little bit on the size of the data. If you're trying to keep like a number secret, or a very specific kind of combination of words, there is definitely a chance that it could be extracted, and there's there's going to be ways of prompt engineering all kinds of data out of the model. I mean, we're not really interested in hiding anything, right? We want the model to be well guardrailed. And I guess the question is then on the implementation side, like, can you really make sure that your infrastructure did and maybe kind of like the maybe even you have an additional level of security around the prompts, can you catch attempts and foil attempts to extract client data, right? But on the level of the model, we just we have to work at it from a particular scale. And for the second part, recommending RAG over fine tuning, Well, it's kind of a question of responsibility, right? With RAG, the onus is, completely on the engineering side. You would have to trust, your database, your data lake, or whatever you're using to connect the different parts of that software engineering solution, right? Whereas with fine tuning, you're trusting that pipeline and you're not, and you're basically isolating yourself maybe potentially from the later questions. You're outsourcing those issues to another part of the stack, which might be a good thing to do, right? Because we do have very powerful serving platforms, architectures emerging right now. The field is full of attempts to solve this problem, and it might be smart to actually, not try to solve everything, but really to limit exactly your scope of responsibility and say, like, the data is safe up to this point, and at that point, it's a handover to your security team or to the security solution that you have in place. But yeah, if this is also something that we'll definitely be addressing at our upcoming seminars and conferences. This is a topic of a lot of interest here, even though it's not directly a research goal of ours.
And then the last question is the impact of the legal filters from the EU AI Act. What impact do those filters have on the final performance of model compared to traditional LLMs?
It's about 20%. No, sorry. There's a separate paper on that from the Apertus team. It is, I'll give you the link here. So we have actually evaluated something we call the data compliance gap, and it's so Fan and all. Let me just give you the link. Yeah. They've run the benchmarks, and they've tried I mean, they've shown the different editions of the weights with and without, in this case, news agencies data, so media data coming from media sources which are restricted by licensing terms. And I think that it's not a fixed number, right? But I think the point is that it's not a huge number, right? It's a manageable loss in quality, and it also is a loss that is understandable. It's like, the model is not going to really be able to understand, like the in-depth specifics that were mentioned by some local news team at some point, right? That event will not be in its memory. It's just not there. But, the general understanding of that as such of an event is possible. And then, if you link it to a web search process, you can retrieve that data in a compliant way. That's absolutely understandable, right? So I think the point is that that people should not be intimidated by claims that frontier models are powerful and can only be powerful if they have unrestricted access to everything in the world, right? That's just not the case. But more like the idea that we want to have ownership, we want to control things in a more, strict way. We need regulation around a lot of this, what this industry is doing, needed as soon as possible, needed yesterday, right? But we're not going to get to sensible. We're also going to be over-regulating things without understanding how these things play in. And we're trying to focus on multilingualism, compliance, and openness. Those three aspects. It's a long-term research area, and we hope to help people drive meaning from these results. So thank you so much for that question as well.
Thank you so much, Oleg, for answering all the questions. Thank you, everyone, for your questions. I'm going to hand over to Vukosi to close us off. But thank you so much.
Cheers.
Okay. Thanks a lot, Oleg, and thanks everybody also for joining in. I think thanks to the Apertus team for also just going over just a little bit in this case. For everybody else, what's coming through in the near future, we should hopefully have one or two more talks that are from other groups that are also still building, and then also then looking especially at evaluation. If you do have some names of people that you would like to invite, we still have a few more months in 2026, and I think this topic seems to be getting bigger and bigger.
So please do email me. You can use the dsfsi.info@up.ac.za. But yeah, and then thanks for all the resources from Apertus that they put in the chat. The chat will be available for people to be able to access after this and then be able to get. So thank you and enjoy the rest of your day.
Thank you very much again to all, and likewise. Best wishes from Zurich, and see you again soon.